Okay, so here we have a picture of the Milky Way taken from Earth. Now, as we discussed last lesson, we can't actually take a picture of the whole Milky Way because we are part of it. It's a bit like trying to take a selfie. You can't take a picture of the whole of yourself, you can only take a picture of part of it. You have to get somebody else to take the whole picture. So, each one of those individual white spots is a star. Now, we are used to seeing one star in the sky, and that's the Sun, and that's the one at the centre of our solar system, which is the closest to us. Now, again, last lesson we looked at the galaxies. Well, there's different kinds of galaxies. So here we've got some spiral galaxies, which is pretty much like the Milky Way is. We've got a cartwheel galaxy, and we've got what we call a sombrero galaxy. There's others as well, but these are just some of the ones we've got. And again, somebody asked the question last week, so what is at the centre of a galaxy? So I'm just going to sort out a few questions from last lesson. Right, scientists believe, I say scientists, physicists believe one of two things, depending on their school of thought. One of them is that at the middle of it there is something like this, which is a nebula, which is basically a giant dust cloud full of hydrogen and helium, which is, as you know, what was there when they started to make the stars, right at the beginning, just after the Big Bang when everything started to cool down. So it has the potential to continue to make stars, to continue to make these solar systems that we know exist. That's one thing. Another one is that some people believe there's actually a black hole in the middle of the Milky Way and in the middle of quite a few other galaxies, if not all of them. We have no way of proving it because we've never been to the middle of the Milky Way. Okay, so each one of those individual stars has a finite lifetime. So our Sun has a finite lifetime. We're about halfway through it at the moment. But when it comes to the end of its lifetime, it's going to end up collapsing, or at least exploding, or something along those lines. And we've got some pictures here that we've taken from the Hubble telescope, which is up in space, where we can actually see what happened to stars. I have no idea what the names of them are. That one there is showing the star just as it starts to explode. You can see the gas cloud and the helium and the hydrogen being flown off. That is the point at which the other elements are starting to be made, as the helium bangs into each other and makes bigger elements. Okay, then we've got the possibility, which could happen, once you've blown off all the gas and everything, that actually implodes. And we'll see in the next slide that that's something that happens fairly regularly. And then we've got this one, which is called the Hourglass Nebula, and it's got the explosion going out mainly in two directions, and that all comes down to how the star explodes, and each one is different. Okay, so the life cycle of a star. We start off with a nebula, that cloud of dust, that cloud of hydrogen and helium, and then depending on when they come together, when they get closer and closer together, the hydrogen and helium, then they're going to start giving off energy again because they start to get hot, and you get what's called a main sequence star, which is what ours is at the moment. It's let's say about halfway through its life cycle, and this is what the classic star that you think of that gives off heat and light. But depending on what size it is, one of two is going to take one of two routes. So it's either going to become a red giant, the smaller ones, or it's going to become a supergiant if it's a bigger one, bigger. If it's a supergiant, then the chances are that it's going to go supernova when it gets towards the end of its life. So a supernova is a big explosion where it blows off all the hydrogen, helium, dust that's left, and it leaves it with a core of solid stuff. Now either that core is going to be very, very dense, in which case you get a neutron star, or it will be so dense that it actually collapses on itself and you'll end up with a black hole. If you've got a smaller star, then you're going to end up going through this route, and you'll end up with a series of dwarfs getting gradually smaller and smaller and denser and denser.